Hi everyone, welcome back once again in our Tech Talk. Today we are going to be talking about testing and all the details about testing. We have a testing expert with us, which is Amit. Thank you, Amit, for agreeing to talk about testing. I know you have years and decades of experience on it, and I'm very excited to find out more about testing from you today. So yeah, I will hand it over very quickly to you without wasting much time. So I'll start with what the most foundational question: what is testing? I mean, we say test engineer, test automation engineer, but what is testing in IT industry?
Thank you so much, Rinat, for the introduction. And yeah, I have got about 14 years of experience now working in the software industry as a tester, test consultant, test manager, test lead, senior QA, whatever you can call it. And yeah, so got loads of experience and testing different types of applications, ranging from mobile applications and web applications to even desktop applications. Now, when it comes to testing, it's something very simple. So whenever you manufacture a product, you test whether it meets the requirements for based on the decisions which the business has taken, based on the requirements for which the product has been created, or based on the user's needs. So if a product is able to fulfill those criterias, we pass it and then we release it in the market. And in order to validate whether everything has met the requirements for the business, for the process, for the product, technical, everything, we do some testing. So you test, say, an aeroplane, you test a computer. So similarly, you test softwares. So software testing is essentially testing software before it's handed over to the customer so that the customer can start using it.
Right. Okay. So how subjective is this testing? I mean, obviously, you're testing the software whether it's good for production or not. But are you testing the quality? Is there like a range of outcome in terms of quality, or is it just yes, no? Is it just binary that okay, is it good enough or not? Or is there like a degree of acceptance criteria?
So that is a very good question because it's a very broad question. So it covers a lot of things. Let me start from the beginning. So when we talk about the quality of a product, what are we talking about? Quality from a business perspective, whether we can maintain the code, whether we can maintain the product, whether we can provide support. Quality from a customer perspective, whether I'm able to do the thing that the product is designed to do or the software is designed to do. Am I able to do it? And then quality in terms of how's the performance. Does the performance degrade over time, or does the performance degrade when other applications are open in the background? Things like that. Then quality in terms of can I open it in multiple browsers, how secure it is, and then does it work for different types of people who are disabled, who can't read, who can't write, who are colorblind, things like that, and all that defines quality of a software, right from the business requirement all the way to the consumer requirement, and that defines the software quality. So there is not one single parameter, there are multiple parameters. So the when we talk about software testing from a company point of view, there are some explicit things. The explicit things are the software should do this, the consumer should be able to log in, the consumer should be able to buy something, the consumer should be able to interact with it, etc., etc. And then there are some implicit requirements which are not clearly defined but which a consumer expects. Things like performance, security. I don't want my data to get leaked. I don't want my software to perform less over a period of time or when multiple applications are open. And I want my software to work on different platforms or different web browsers, things like that. So those are implicit. And all this together encompasses the software quality. So yeah, in short.
Right, right. Okay. That is very interesting because as a developer, when I'm given like a list of requirements, I'm always thinking, I mean, I'm usually, you know, categorizing it into two things. Like one is mandatory requirement and the one is nice to have. But what you mentioned right now is the implicit requirement, is what the customer expects by default. That's something I haven't actually thought about before, because that's a very interesting thing to always take into account. That okay, there are nice to have things that would be, that are, that will delight the customers, but if what they're actually, their minimum expectation is not met, then no matter how many nice to have features you have, that's not going to be good enough. So definitely that's actually a very, very important eye opener for me as well.
And I
So
mean, just to add to what you said, because yes, as a developer, you focus only on the requirements and you are not this. But when we talk about software quality, we also want to understand who's responsible for the quality. Is it actually the tester or the developer or the business analyst or the product owner or the project manager or the organization? Who's responsible? And always the answer sometimes says testers are the gatekeepers. They are the protectors. They are the torch bearers of quality. But no, quality is a responsibility of everyone in the organization, because how the
yeah.
organization interacts, communicates, drills down the requirements, how the product owner defines the requirements, how the developer builds the software, how the test actually tests the software, and then how it's released and deployed. All that forms quality. So it's not a single entity that's responsible for quality, it's the whole organization.
Yes, absolutely. I mean, I very much agree with that. And I remember of a story of a car manufacturer. I'm not going to go into the names of that, but basically what they were doing, the way they were manufacturing, is that they had, in their assembly line, they had various, stages. And then they had a last stage, which is basically finalized stage. Like, if there was any problem, any tiny defect or anything at the last, in any of the previous stages, then that last stage would basically finalize everything, give the finishing touches, perfect everything before the car is sent out to the public. But one of the researcher or sort of process optimization expert came in, and they analyzed this whole thing, and then they finally recommended that get rid of that perfection, get rid of that last stage altogether, because what was happening is everyone was doing a half-assed job. They were thinking, oh yeah, we've done 90%, but okay, let the, that last stage deal with it, make them, let them make it perfect and deal with these small problems. But then obviously with all of these steps in the assembly line, it really does add up, and it also takes away the responsibility from each of these stages. So as soon as it was gotten rid of, then everyone had more ownership, and everyone took more responsibility in terms of keeping the quality of the product up to their highest standard. So yeah, absolutely, there is strategies there where everyone should be incentivized, so everyone
Yes,
can sort of maintain the quality. So
yes.
yeah, no, that's I actually, I'm quite passionate about this part. That's why I thought I'll explain it a little bit more.
And
um
while you were mentioning that, sorry to interrupt, Rinat, while you were
no,
mentioning
no.
that, I also realized there is something called as test pyramid, which actually, I'm not sure if you're familiar, but in the testing world, whenever you go for an interview, they ask you about the test pyramid. And the test pyramid basically says, when should you test and how expensive will it be to test at that stage or that level. Okay, so if you test it early, you save a lot of money because you have a lot of time after during development. But if you test it very late, it becomes very expensive to fix things. Just like in your car manufacturing example, like if you try to fix everything in the end, because you have to go back, and then the supply chain and everything, the logistics, the assembly, manufacturing, all the processes have to be again realigned to fix that one simple issue. It's going to cost the
Yeah.
company a lot of money. So similarly, I mean, with the analogy of manufacturing, the same principles apply to software testing as well. So it's more expensive to fix a software close to delivery, but it's much cheaper to fix a software at the beginning. And at the beginning is right before you even write this first line of code. It's actually at the time of writing the requirement. If the requirements are crystal clear, if the design team has thought about the right architecture, then it's very simple to code. I remember this one quote from Einstein who said that if you have if you have a minute to solve a problem, or say you have 10 minutes to solve a problem, not a minute, 10 minutes to solve a problem, I'll spend 9 minutes to think how I would solve the problem and 1 minute to execute my solution. So
Yes,
you need
yes,
to
no, I
spend a lot of time in designing and thinking and how everything will be done, and then you execute. But a lot of times what happens is people forget all that and they just focus on let's build without caring about everything else.
I was just going to say that we know the ideal scenario, but in my experience, even like, like it's just that's not how the companies or the businesses deal with things. But yeah, I mean, the output would be so much better if we had a planned infrastructure or like a step-by-step method to follow this, and may we would have made a lot more out of that, the same resources and same time after that.
Yes.
So another thing also I'm curious about, obviously we were talking about the quality and also thinking beforehand. So one of the other thing is what I also experienced, that that setting the success criteria or acceptance criteria of a software or any product at the beginning is very important. So
Yes.
when it comes to your time to test, do you look at the initial success criteria that was set up and do you test against that, or what in your experience does it always change? I mean, people set out that okay, we're going to do this and this, but then by the time they built it, the target or the objective may have changed. I mean, what's your experience or thoughts on
So,
that?
I mean, from my own experience, what I do is I always look at the requirements because the requirements are guiding us. And if there are no requirements, then what you do is essentially you think of how a customer would use a product and then define it. So suppose the acceptance criteria is actually there written in the requirement. What I would do is I would look at the acceptance criteria and then see if it passes or fails or whatever based on the acceptance criteria. So that's my bare minimum of testing. Apart from that, what I will do is I will also do some exploratory testing, do some negative scenarios, because most of the times, if you see, acceptance criteria are happy paths or positive scenarios. They are not about failures,
Right.
they are not about errors, they are not about negative scenarios. What I mean by negative or failure scenarios is what happens if something breaks, what happens if something fails, what happens if the data is not received, what happens if the database is down, etc., etc. So those are the negative, unhappy path or the failure scenarios, and that also has to be tested. So as a bare minimum, test the acceptance criteria because that will definitely help you to even understand sometimes the software, because as a tester I've noticed that you have a much broader picture of the whole system than maybe a developer, because
Right.
your perspective is all about testing the whole system from a consumer point of view, also testing the requirements and also testing many other things. But in the end, you're trying to uncover issues with the software. So when we actually test software, what are we trying to do? Am I trying to break it? No. Am I trying to, what am I trying to do? Basically, what I'm trying to do is I'm trying to uncover issues. So, like you develop UiPath robots, right? And I'm testing those
Yeah.
UiPath robots. From your perspective, you have built something, but you don't have time to test it. So, and when I say test, it means uncover any issues with the development of the robots, or whether the robot is functioning right in the right scenarios. So I come as a tester, I test your robot, and I say, Rinat, this is not working as per this design or as per this requirement, or it is not working as per what you intended it to do. It is doing this, it is doing that. So I'm actually uncovering issues. I'm not trying to break the software. People say testers break softwares. No, we don't break softwares. We uncover issues in the software. It could be a human
Yes.
issue, it could be a process issue, a design issue, various things. But at the end, our aim is to enable you to develop a better product. And we are not trying to find faults. A lot of times, testers and developers, they have this big tussle among themselves saying, oh, I'm a developer, I'm right, I've coded it properly. And testers will say, no, I have tested it right, I know what I'm doing. You have not built it correctly. But I think we need to understand that we are here to help each other deliver something together.
Absolutely. Yes. No, that's yeah, actually has been a really good experience so far with you as well. I mean, there has always been that communication, give and take, and at the end of the day, if we all try to meet the final objective of producing a very robust software, then obviously the objective becomes clear that what needs to be done to get to the final stage.
Yes.
So, okay, so moving on from that, when we talk about testing, I mean, obviously, you're checking the software. I mean, obviously, you mentioned, you want to uncover weaknesses, etc. But I mean, people call it sometimes they're just calling it that you're checking the development or the coding. But what is there a difference between testing and checking? I mean, I check as well when I develop, but I'm sure there is more to testing than that.
Yes. So there is a difference. In testing, what we are trying to uncover is how the software actually behaves. And checking is to ensure that it behaves always the same way. So
Right.
testing is basically uncovering the behavior. So suppose you have developed something and you have not told me how it behaves, how it works. And I as a tester comes and then I take a notebook, I take a pen, I try to do something with it and it does something and I take a note. And that note is basically trying to establish, okay, this is how the software behaves. So that's testing. And when I check, what I do is I look at the notebook, I look at my note, and then I say, okay, this is the note, and the software should behave this way. Is it actually behaving that way? So that's checking. Okay, so there is a difference. There is a difference in the sense that a lot of people say automation is going to solve all the problems and it is going to replace all the testers. But what is automation doing? Automation is only checking, it's not testing. It is checking what has been coded in the automation script. So suppose you are building a UiPath robot to do some automation, but you have defined
Yeah.
how it should behave. So it will behave exactly the same every time it runs, right? So it is not going to behave in any other way. As long as you've coded it right, it will behave exactly the same. So when I check whether it's behaving right or not, I'm checking that this is how it should behave. But when I test it under different scenarios and see how it actually behaves if I disconnect the internet or if I close the database or I break the connection, things like that. And that is not checking
Right.
because you have not developed it for that. And then when I say, Rinat, it is not working in this scenario, then you develop it even better and you capture those scenarios and make it more robust. So that's a slight difference. So automation is doing checking, testing is uncovering things which you can't know beforehand.
I see. That is very intriguing to know. Actually, I've never thought about it this way, and I didn't realize that so many things actually go into testing. You have
Yes.
to sort of have so many logic as well. I always thought, I'm developing, and after developing, I'm running to see whether it runs. So I'm kind of doing half the job of tester anyway.
You
But
think that, yes.
of course, there is more to testing than what the developer does. So yeah. So that kind of brings me to, like, I'm sure there is, like, what are the main principles of software testing? There's, surely like a set of things that you follow or you have to know about when you're testing, and no anyone can just be, a developer can't just be a tester, right? So there is, what are the main principles of testing?
So, I mean, for a tester to test software or anything for that matter, you have to be curious, you have to be able to communicate your ideas or whatever you have observed clearly. And the principles are actually very simple. It's basically is a couple of principles, five or six, I think, that are standard now across the industry and everyone is aware of it. And one of them is like you cannot test the entire software 100%. So we say, yeah,
Okay.
I have tested 100%, but no, you have not tested. You can never test it 100% because you are limited by your own knowledge, by your own experience. A person is always limited. A organization is always limited. A software is similarly limited, and we cannot comprehend all the possible scenarios in which the software will be executed. So, as a tester, I try to execute in as many possible scenarios that I have experience in, or as far as many scenarios in which I'm for which I'm aware of. Okay, so that's one thing. The second thing is whenever we are testing, we will uncover defects or issues. Okay, so we are uncovering issues, right? So it's not like we are creating issues, we are breaking anything, we are uncovering issues within the software. Okay, and then you have this mentality that there is another, I mean, this mentality that if I test the same thing again and again, I'll uncover new issues, but that's not the case. Because if you test the same thing again and again, which happens actually with automation, because you're testing the same thing again and again, it will not generate new issues because you have already fixed them. And after a certain period of time, you would have fixed all the possible issues, and then you will not uncover any new issues. So if you keep on testing or executing the same test scripts, as they say, you'll not uncover any new issues. Okay.
Ah, okay.
And then the defects normally tend to cluster. So in the sense that you know about the Pareto principle, where it says that 80%
2020s.
of the
Yes.
problems are caused by 20%, sorry, 80% of things happen because of 20% of a problem. 80-20
Yes,
principle,
it's actually
basically.
very.
Yeah.
I'm actually very, I'm very passionate about this principle. I apply that to everywhere in my life, and I have found so many positive outcomes from that. It's just amazing principle. Yeah, yeah. Go on.
So in software also you apply the same principle. 80% of the defects actually come from 20% of the code, right? So majority of the defects
Yes.
tend to stick or cluster in some part of the code. The remaining part is less complicated and produces less issues. So if you think, for example, that whenever we are trying to test something and whenever we are short of time, we always test the most complex part of the software and the most riskiest part from a business point of view. So payments are always the most riskiest, and most complex is also the integration between two systems. So those are the places where you can actually have most issues. If it's a simple login thing, or if it's just a simple text input, more or less it will work. But where the integration happens, where information flows from one system to another, that's where the problem occurs. And it's actually very simple to figure that out normally. And
Right.
as I have tested your robots, you would have seen that most of the defects are from just one particular area of the code. It's not the
Yes.
entire
Yes.
code, it's just few bits and pieces. So that's another thing. And when we are testing, it it tells us that I mean, it tells us the issues or everything based on how or what is the context behind our test. So suppose I am testing just for security. So I
Right.
will try to uncover only defects which are related to security. I'll not try to cover other scenarios or anything else. And similarly, if I'm trying to test for performance, so I have to define the context in which I'm testing. What is the reason? What am I testing? What is the context? So that also defines how the testing is driven. I mean, those are more or less the guiding principles for any testing, software testing project.
Right. Okay. That's actually very interesting to know. That definitely like helped me understand, whenever I'm doing something, then now I can have a better understanding of where my work is going and how it's, being tested or treated after me. So there is one thing that I have heard this term called pesticide something. pesticide paradox, is it? And I always wondered what that is. What is pesticide paradox?
So, pesticide paradox is something that we already just spoke about. Like, if you test the same thing, you will not uncover new issues. So that's the pesticide paradox. So don't keep testing the same thing again and again, or don't run the same test scripts again and again. So if you have some test cases or test scripts to run, then don't try to run them again and again, because they are not going to find new issues. So you will have to update them or find some new scenarios to execute in order to uncover new issues. So that's basically the
Right,
paradox. just because
right. I
just
see.
because you think that there are no issues doesn't mean there are no issues. There might be
Okay,
issues,
okay,
but you
yeah.
have not
No,
been able to uncover it.
I see, I see. So basically, you have to expand your like search
Ex-
criteria of issues, and then,
Expand, change, yeah, expand or change, I would say. Don't stick to what you're doing every day.
of course, yeah, no, that totally makes sense, and that can actually be applied to our regular life as well. I'm sure a lot
Definitely,
of
yes.
yeah, a lot of problems will be uncovered that way. New problems in life. So I'm sure there is, obviously testing. This is a, like a proper like industry, or like there is probably like a, various methods, or like what do you call it, the, like, when you approach something, you want to categorize your problem. There is, so what in software testing, I mean, how do you do that? What are the methods of software testing? How do you approach what kind of problem it is and
So
stuff
in
like that?
software testing in general, you have so many methods, and not every testing is actually about actually running a code. So there is something called a static testing, where you just look at the requirements, you look at the code, you read it. So you don't execute the code, you just read it. You read what has been built, you read the documentation. Because when you're talking about quality, it also about documentation, the code that has been written, has it been written properly, can it be maintained properly, how is the requirement, can I test the requirement. So sometimes what happens is a product owner decides to write a requirement. Okay, and then the tester comes and says, guys, we can't test this requirement because the environment is not as available, the scenario is not possible, the software should not behave this way, etc., etc. So sometimes you just test the requirement. So there is this term called testability of requirements. Can you actually test the
Right.
requirements? So a lot of
Okay.
times people say, why do you need testers in a requirements planning meeting? But you need them because they can tell you whether we can test it or not. And sometimes what happens is, especially in agile teams, testers, developers, product owners, business analysts, scrum masters, they're all working together. And tester and the developer will say, yeah, it will just take 2 hours to develop and code this feature. But the tester will say it will take 2 days for me to test. And then everyone will start looking at the tester and wonder, why is that the case? Why will it take 2 days? But the thing is, when you just modify a bit of the code, sometimes code has an impact on the whole system. So you have to test everything around it.
Yes.
So sometimes that
Yes. Yes.
complexity only a tester would know, and that's why it would take, instead of 2 hours to just code, it will take 2 days for them to test it. So that's one
Of
method.
course.
So that's like just looking at static. Then dynamic. The dynamic is code execution. So you execute code, you run it, and you see what happens. So that's dynamic. The other method is you don't know anything about what the code is. You just try to run it. So sometimes you know what the code is in the background, and when you know the internal mechanism of a software, that's called a white box testing. Okay, so you know what is there
Right.
inside. If you don't know what is inside, then it's called a black box testing. So think of a CPU. Okay, so if I know what is there inside a CPU, I can try to debug it and try to identify the problem, or the the bonnet of a car, if you open it, you see the engine, you see the radiator, you see the oil filter, water filter, etc., etc. And if you know how everything is connected and works, you can actually fix problems. And if some problem occurs, you know where exactly the issue is. So that's white box.
Yes.
So you know the internal mechanism. But there is something called black box. You don't know anything. You just switch on the ignition of a car, or you just take the software and you just do whatever you want to do with it.
You
And
just
that
you
is black
just
box. Okay.
right. You only have you can just input some things and see what output it comes out, and
Exactly.
then try to make out what's happening inside.
Exactly as you have described. Exactly as you described. Okay, so that's black box. Then some people say, okay, I don't care about what scripts are written or what this is written. I just want to explore. I just want to find my way around the software. So exploratory testing. No, nothing is defined, nothing is planned. Then you have agile methodology. So agile methodology. In agile methodology, you test always. You always keep on testing. So there are
Ah,
different
okay.
methods like that, and there are some more methods. When you say manual testing, humans are testing. Well, humans are testing. It's not manual testing. Uh, just because humans are testing it, we don't call an aircraft that is being tested by humans a manual testing, right? So similarly, we should
No,
not
no.
call manual testing or automation testing. This is a very misnomer, and a lot of people in the industry have come against this whole term of manual testing and automation testing. It is not manual. Humans are doing it. Why are we calling it manual? We don't call something else manual. So why are we calling testing manual? So yes, so these are the
Yes.
different methods of testing.
So you mentioned white box and black box. Is there something in the middle, like brown box, or
Oh
maybe
yes,
not
there
brown
is
box, but
something in
gray
the middle,
box?
gray box. There is something in the middle,
Gray
gray
box.
box.
Yes.
Yeah,
Sorry,
yeah, yeah.
that was.
It's like you're neither white nor black. You're gray. It's like that shady villain in a film, right? You're neither good, you're neither bad. You're in between. So it's something like that. So it's a mix of black box and white box, and that's called gray box.
So why would there ever be a black box? I mean, when you're testing something, would you not get all the information that you need from the developers who developed it? I mean, they should tell you everything, all the inner workings. That way, you don't have to have gray or black. You just have the white box with all the information. Isn't that easier for you?
So that is easier, yes, and that is only in the case where you actually have testers testing it. But what about consumers or user acceptance testing, as we call it, when they come into the picture? So
Right.
you know you have beta testing.
Mm-hmm.
Whenever you release a
Yes.
software, there is a beta release, alpha release, and so forth. Those are
Yes.
early release of a software to consumers, and or you invite few consumers in your organization, you ask them to test it, and they don't know what the system is, they don't know the code. Those
Right.
people
Yeah.
will actually do black box testing because they don't know the internal mechanisms, right? So when you get a beta
Yes.
software, you don't know the code. You just test it. You actually don't even test, you just use it. And when while you're using it, you uncover issues. And we call it testing,
Right.
but you're just uncovering issues as you use the system.
Wow, that's very eye-opening, to be honest. That's very interesting. Is that just made me think of a whole new thing about perspective, because I was saying black box testing is bad, but actually, if you're doing black box testing, that means that you're not biased by all the things that you know. You're just replicating what an user would do. So that's like, a fresh set of eyes. You're just trying to be the user, and that's a
Exactly.
completely different level of testing, and that would bring out, a fresh perspective, and that would uncover new different kind of errors that, when you're not biased by knowing all the way it works. Because
Yes.
if you know everything, then you kind of, you found something, a weakness, and you thought, oh, I know why this is like that, because this is coded that way.
True.
But if you're a user, then you don't care about how it's coded. You want a feature and you want it working the best. So yeah, that's actually very interesting. That's very eye-opening thing to know.
This actually happens quite a lot. This bias. So
Mhm.
people who are experienced in testing, sometimes they develop this bias because they all, if you are in a project for a very long time, you tend to always test specific things. You don't test it like someone with fresh eyes. So
Yes.
the alpha testing, beta testing, or user acceptance testing is actually quite important because they are going to test it in a way which you would have never thought of. And that's why a lot of big
Mhm.
companies, they actually put out their software as a beta release because these are people who are going to test the software for you free of cost. you
Yes.
would you would get a tester and you would pay them some money and they would do some testing for you and they'll find some issues, but of course they would be limited by their experience, their awareness, their knowledge, their skills. When a person comes, or say 10,000 people come to do beta testing of your software, that's where you uncover so many other possibilities, so many other ways where people would have not even imagined how it would be used, right? So
Yes.
so
Yes.
I'll give you one example. It happened with the Galaxy Fold. Okay, Galaxy Fold,
Right.
when it was launched, it had this huge like fanfare and everything. Like it was a lot of hype in the media. Oh, this is a very good phone. This phone, that phone. And they said we can close it and open it, close it and open it 10,000 times. So or n number of times. Okay, but when people
Hmm.
started actually folding the phone in a closed position and putting in the pocket, and that's where things started creating problems. Because when you are putting it in your pocket, it starts rubbing against the surface of your pants or jeans, sometimes rubbing against the skin or whatever, and that causes wear and tear. And they found out
Right.
that when you keep it in the pocket or something like that, the screen actually gets some dust, does this, does that, and breaks. And then they
Right.
also had a coating on the top of the screen. So whenever you buy a smartphone, you have a film or a plastic cover that
Yeah.
covers the screen, and then you peel it off. So a lot
Mm.
of people thought that that is a similar packaging, but actually that peel was
Mm.
not supposed to be taken off. So a lot of people took off the plastic cover and it damaged the screen. And there was no disclaimer, there was no
Yeah.
instructions. And this is a very simple
Right. Right.
example. This is not even software testing, but this is testing for a product and
Yes.
using it in a way that it was never designed to be used or never even thought it could be used in that way. So yeah.
Right, right. I mean, this is actually like so interesting because this is actually, I mean, before I was just thinking testing is, test engine. There is test engineer who does the testing, and as long as the success criteria is met or some requirement is met, that was it. But actually, now I realize, like it's such a broad spectrum the testing. I mean, it's not just test engineer. It's just alpha testing, beta testing, so many things I didn't even think about. So that actually makes me think like there must be different levels of software testing. I mean, when I do a little bit of development, I just test that. I know that's called unit testing, but there must be various other levels as well. Tell us little bit about that.
So I normally use a very simple analogy to explain the different levels of testing. So a lot of people are familiar with a desktop, a CPU of a computer.
Mm-hmm.
Okay, so let's start with the processor. So if you hold the processor in your hand and if you test anything on the processor, let's call that unit testing. Then the processor is put on the motherboard. That's called integration testing. So you test how the processor works with the motherboard. Integration testing.
Uh,
Then you put the hard disk and you connect it to the motherboard. That's again integration testing. You connect the RAM and you do integration testing. You connect the graphic card and that's integration testing. Okay, so that's the second level. Third level is system testing. So now what you're doing is you have connected all the things. You have connected the CPU, you have connected the hard drive, you have connected the RAM, you have connected your graphics card, you have connected your power supply. Now as a whole, you do the testing of the whole thing together.
right.
So that's
Okay.
system
Yeah.
testing or what they call system integration testing. And then you put
Right.
it in a box. You cover the box and you put a fancy label on it and you give it to a customer. And the customer or whoever is using that It's called either a black box testing or a user acceptance testing. So these are the different levels
I
in principle of testing.
I see, I see. Okay, no, that is very interesting as well. Because I mean, I thought I'm doing unit testing, but of course, when I hand it over to, for example, you as testing engineer, you obviously then there is, all of these things that you're doing to make sure that it's fully integrated into the whole ecosystem of, all the technologies that are in that premise. So yeah, that's quite cool actually. Um, what kind of tools do you use when you're testing? Is there like your software applications, and what else do you use to?
Predominantly, we use software to record and take screenshots. So any software that can take screenshots or can record a video is essentially a good testing tool because you want to capture what you have observed, right? Because if I want to tell a developer or someone who has built the product or designed the product, I want to tell them that this is the issue that I've uncovered. I need to be able to explain to them. So my toolkit should have a way to analyze logs. So I normally use, I get access to a database, so I look at the logs or the content of a table. I look at, I try to take screenshots, I try to capture videos to help people understand. Those are the simple tools. Then you also have a notepad, a pen and paper, so you take notes. So that can be a simple tool for testing, because when you are testing you sometimes forget. So that can be a tool. And then you will use some tools to manage the data. So as a tester you have access to multiple systems, and multiple systems will have multiple logins, URLs, usernames, passwords, etc., etc. And to manage all that, you need a system. So I use something called as a password manager to manage all the usernames and passwords, so that it helps me to quickly uh, get access to a system whenever I need, whatever I need, and whichever environment it is. So everything in one single place, yeah, that helps. But yeah, these are some of the simple tools that you can use. But the biggest tool is your brain, your intellect. That is your biggest tool, because you are trying to be curious in order to understand how the developed code is working.
Of course, yeah, yeah. To have that kind of like searching mindset, to like the
Yes,
exploratory mindset that what, and you have to also have an open mind so you can think like the broad, the looking at the broader picture of how it's going to be used in the end, etc.
yes,
So another thing I actually wanted to add as well. I mean, I know this is not a tool for you to test, but as a person who interacts with the tester, one tool I actually found really helpful is called Process Steps Recorder. It's actually integrated within Microsoft Windows, and I found this to be useful because it's a lot of the big organizations have a lot of security or restrictions on
yes.
using various applications or even taking screenshots or taking video, things like that. So this is, if you just press the Windows button, bring up your starts menu and type PSR, P for Papa, S for Sierra, R for Romeo, and then it would come up, and it's a steps recorder. You basically just literally um, click record and then do the exact steps, replicate the problem, and it will take screenshots of each of the steps that you have taken to get to that problem. And
Oh,
then you can send that easily to a test engineer so they can see what's happening.
oh,
And
interesting.
also, I mean, yes, yes, and I was stuck in one with one of the clients because they had so much security restrictions. I wasn't allowed to take screenshots. I wasn't allowed to install any software. I wasn't even allowed to use a web application, or a Chrome extension or anything like that. So I just, somehow came to know about this, and this was a lifesaver for that situation. I was able to take step-by-step screenshots, automated.
Nice.
Once you do the replicate the problem and you stop recording, it would create you a report, and you can just send it off to whoever needs to see the
Okay.
problem.
I'll try this out because this is quite interesting. As a Windows user, I quite fancy using tools which are inbuilt, and if that helps me to test better and record my steps better, then I definitely want to use it. But while you were talking, I also came to realize that I myself use two other very important tools. One is a portable apps tool. So normally what happens is when you are not allowed to install software, you can still
Uh-huh.
download them. You may not be able to install them, but you can still download them. And what I try to do is I download portable applications that can run without installing.
Right.
And
Okay.
those are quite
Yeah.
useful, so especially in Notepad++ when you're looking at multiple code, because the Notepad itself is not that capable enough to look at multiple formats of code,
Yes.
etc. So I download Notepad++. Then there is one tool
That's
called
actually one of the. I mean, as soon as I
Lifesavers.
create a VM, the first two things to install is Chrome and Node+++++. That's
Yes,
just, yeah,
yes,
that's
it
just
is.
like
It
a
is
default.
a lifesaver. So Notepad++ is one, and the so portable apps, and then the other software I normally tend to use is AutoHotkey. So AutoHotkey,
Okay.
or AHK as it stands, is basically a way to automate Windows or things in Windows. So GUI based
Mhm.
automation, but it's beyond GUI based automation as well, because it can do many other things like text expander. So suppose you do a certain task repeatedly, you want to automate it. How do you automate it on Windows? So you write a simple script. If I press this hotkey, it will execute that command. So it's essentially a batch script, but in a particular format. So, like, I have a hotkey to take screenshots. I have a hotkey to take a screenshot, put it in MS Paint, and then save it in JPEG and name it in the timestamp and save it on my desktop. So with a
Ah,
simple
that's
hotkey,
cool.
I've automated everything. Then I have another hotkey where if I have to send an email every time to a person, or to say 20 people, and I don't have a group. So I just write three letters and it expands into the whole list of email addresses. So it acts as a text expander. So yeah, things
Wow,
like
that
that.
is.
So it's a productivity tool. Things that you repeatedly do as a developer or as a tester, you want to automate it. So yeah,
Yes, absolutely. I mean, to be honest, I wasn't aware of this auto hotkey. I'm definitely going to use it. That sounds really cool. I mean, if I knew about this before, my life would have been so much better.
I
But no,
know.
definitely, I'm gonna I'm gonna use that from now
And I will use PSR. I'll have a look.
on. Okay, cool. Okay, so I know we in the beginning of this talk we very briefly talked about quality, but we didn't really go into much detail. We just mentioned quality, but I'm sure there is a lot more in quality as well. I just want to come back to that point because I think it's a very important one. Tell us more about that. What kind of like different levels of like quality control, quality assurance. There must be many, many things related to quality. And how do you deal with that?
So yes, so when we talk about quality, we are not talking about how the software works, but how the software is used, how the software is developed, how the software will be maintained, etc., etc. So when we talk about all these things, testing just becomes a part of it. It is not everything. It is just a part of it. So at an organization level, you normally have quality assurance. How do you make sure that defects don't occur or issues don't occur in a software? So how can you ensure that you have robust documentation, you have people who are technical enough, you have people who understand the system, they are built correctly, everything. So and at and how the organization thinks, how the organization communicates, that is also important, because there's one very good article written at a blog, martinfowler.com, and he's one of the great thinkers from ThoughtWorks. And he says that most of the software architectures are simply based on the architect or are simply based on how an organization communicates within itself. So if you have a communication hierarchy where the CEO talks to the CTO, the CTO talks to the program manager, it goes down to the project manager, it goes down to the business analyst, developers, testers, then you have this hierarchical model, and the software in your company will follow the same hierarchy. But if your software is built in a startup where everything is agile, where everyone talks to each other, everyone interacts with each other, so you will have a software development model which is close to agile, where things are developed much faster, they are released to the market much quicker, and you get feedback much quicker from the customer, and then you incorporate that feedback and then release it. So based on that, you have different design architectures, and all that from an organization point of view is quality assurance. How do you ensure the defects don't occur? And quality assurance deal with processes. So what processes can you put in place so that these um, quality issues don't occur? Then you have quality control. So how do you control something? So in order to control something, you need to measure it. So how do you measure? How do you control? How do you validate? All those things. And in quality control, one aspect is testing. So testing is what is testing trying to do? Uncover issues in software. So once you have uncovered issues, the developer validates whether it's the right issue or not and whether it can be fixed or not. And once we have found out multiple issues, we can then measure, like in say 100 lines of code, how many defects we have identified. So that is one of the ways to measure quality and then trying to control it by having robust requirements. Okay, so when you have uncovered in 100 lines of code 10 defects, then it means there is something wrong with either the way you have developed the code or either the way the requirements have been written, and therefore the code has been built in a particular way. So that is quality control, and testing forms part of that quality control. So you have
Right.
something from a process point of view and a product point of view. Process point of view focuses on quality assurance, and it's mostly at the org level. And then the product point of view focuses on quality control and mostly at the project level or the program level. So that's
I
again very
see.
interesting because people use these terms very loosely and they are not very clear about it.
That's actually yeah, that's very, good insight to have. It's definitely, yeah, it definitely opened my eyes to understand better on, what kind of things you do and what kind of things you have to consider. So, I mean, I've, now got to know a lot about testing, and maybe I want to become a software, testing engineer. So, what kind of certifications are there that I have to do if I have, if I wanted to dabble into it a little bit more.
So there are a couple of certifications, and the biggest body that awards certifications is the ISTQB. It's a software testing quality board, and they basically award all the certifications related to testing. And it's not just for testers, but senior testers, test management, and etc. So they provide certifications at all levels of a test life cycle. And there is another body in UK called the British Computing Society, I think BCS, and they also award certifications which are aligned with ISTQB model. So yeah, these are the certifications that you can do, you can take. But apart from that, having just a curious mind and be open to possibilities and have that knack to understand systems and try to solve problems and uncover issues, I think that's a good quality anyway to have.
Right, right. I was just going to ask, like, what kind of quality? I mean, yeah, I mean, it's all good to know where I need to be certified, but I need to first be, ready, or have that kind of, like, knowledge and quality of a tester. So I wanted to first ask that what are the, what are the qualities, or what are the sort of the skills of a good
Yes, yes.
tester? But no, I think, yeah, as that's what you mentioned. But
So
yeah,
yeah,
go
I
on.
mean, communication is very important. I mean, a lot of people say curiosity, but communication is important because if I uncover an issue, I should be able to communicate how I uncovered it, what I uncovered, and how can you replicate it in your own system. If I'm not able to
Right.
communicate that, I'm not a effective tester, because no matter how good issues I find, if I'm not able to explain it to my developer, my project manager, my business analyst, then what good is finding an issue? So you need to be
Yeah,
able to
no,
communicate your thoughts, your ideas also effectively. So
right,
when I
right.
say
No,
effective, it means you give all the information in one email. You don't say, "Oh, I found this issue." The developer will then ask in an email, "Where did you find the issue?" "Oh, I found it in that software." "Okay, how did you find this software?" "Oh, when I was doing this." "Okay." Then you will say, "Okay, what login were you using?" Then he say, "I'll use this login." "Okay, which environment was it?" "Okay, what were the logs?" So now you have spent 2 hours discussing issues and problems that you could have done it effectively in one email. This is the test environment, this is the test login, this is the test data, this is the test URL, this is what I tried to do, this is what I observed, this is what I'm expecting.
yeah,
Done. So if you send this in one email, you have saved a lot of time. So that's effective communication, which is very vital to save a lot of your time as a developer and my time as a tester. I don't want to be
yes, no,
sending spending time sending emails.
I couldn't agree with you more. I mean, to be honest, at all levels of, in an organization,
Yes.
communication is so important, and yeah, giving a robust, like a comprehensive email, with all the information the other person needs, just helps a lot, helps, save a lot of time. And, it also helps avoiding miscommunication as well.
Yes.
So yeah, definitely agree. So, okay, so yeah, I mean, yeah, I have the right mindset. I know where to go when when I have all the testing knowledge. But where would I get these knowledge? I mean, is there like public forums, or where do I learn about testing in a formal setting, or formal or informal? Like, where do I get this knowledge?
So normally people who are testers, they have a particular personality. They like to understand how a system works and they try to uncover issues. So they are curious by nature. So once you have these qualities, you actually seek information. And seeking information is just by doing a Google search. So if you are a tester, the biggest body or forum which is quite popular all across the world is Ministry of Testing. So that is a very popular. It's a club. You have to take. There is a paid membership. There is a free membership. They have lots of events, a lot of classes, and most of the big names in testing are actually part of Ministry of Testing. And Ministry of Testing has regional chapters, country chapters, etc., etc. And you can interact with Ministry of Testing by going to their website. They have a forum where you can ask questions about testing, and it's not just testing software but testing process, testing management, test data, test environment, anything, testing tools. You can ask about that, even your testing career if you're doubtful about your career. And then you also have a forum in Slack channel. So Ministry of Testing has a very good Slack channel, and I can't like force how important it is, because my last two jobs were actually through the Slack channel. So I got my
Oh,
last two contracts through the Slack channel. So it's quite an effective medium as well, because uh, testers are trying to help each other out, and they post a job advertisement which you might not be even aware of, and someone just posts it. You connect to the person, you drop them a message, you send them an email, and voila, you fix an interview, and if you clear, you get a job. So that's one thing. The other thing is there are a lot of meetups. So during COVID, I attended a lot of meetups. I gave talks in couple of meetups on couple of meetups for some automation tools. So those meetups are quite helpful. Just type QA or testing, and you would find a lot of meetups in meetups website meetup.com. And then there are a lot of testing conferences where people come and share their experience in testing, not just in technical aspect but business aspect, product aspect, human aspect. So a lot of the those things are also covered in these conferences. And then you have events as well where you can go participate and do testing. So I've attended few events where they are about to launch a product, but rather than getting it tested thoroughly, what they do is they invite a lot of testing people, and they say, okay, we'll give you free food, free beer, and then we'll give you a prize. let's see who uncovers the maximum number of bugs. So it's like a competition it's like a gamification version of finding bugs in a limited
Uh,
amount of time. And that actually excites you
to be
because,
honest,
sorry?
you had me sold at free beer, so I'm definitely going to take part next time.
I know, but they don't occur that frequently. But yes, I have attended such meetups, and it's actually quite fun because you first everyone is testing the same software, but everyone is trying to uncover different issues. And as a tester, you are always amazed at how people are thinking about issues and how they are uncovering those issues in the system. So it's actually quite fun to actually go and participate in such events.
Right, right, right. Okay, no, that is interesting. I mean, now this is like quite a comprehensive set of information. So I know where to get more information. I know what kind of mindset or the personal qualities I need. And now I also know where to get the certification that is actually, like approved or sort of recognized everywhere else. So that's actually a very good path to becoming a test engineer. Thank you for all of those information. Now, I know whenever we talk about testing, I think, part of me always think about, you also have to test the security of it. And then,
Yes.
then the whole arena of cybersecurity comes in. But I think we need another talk altogether to cover the cybersecurity and that aspect of, I don't know if it's a branch of testing or is it a whole area in itself, but it is a very important topic, and we definitely want to cover that in one of our future episodes, I think.
Definitely, definitely. And I think one of the things that we didn't discuss yet is the different types of testing. So we talked about the methods, we talked about the levels, but we didn't talk about the types of testing. So what I mean by types is you have functional testing, where you are testing the functionality of a software or the feature of a code or a product. And then you have the non-functional bit. So explicit and implicit. Explicit is something that is clearly defined. Implicit is not clearly defined, vague. And explicit is functional testing, implicit is non-functional testing. So in explicit, you will have the unit testing, system testing, and so forth. But with non-functional testing, you will have performance testing, where you're testing the performance of a software. And what I mean by performance is what happens when the software is put, is say a web application, a website is connected by 1,000 users at a time. How does the server respond? Is it able to give all the pages? What happens if the 1,000 users remain connected to the server for 10 hours continuously? So that's like
Right.
endurance testing of a server. Then you have stress testing. So when does the server actually crash? You need to know, right?
Mm.
At what point does the server crash? At how many requests does the server crash? So you need to know as an engineer. So that's one aspect. And then suddenly, during Christmas or during Black Friday, you have a sudden spike in users, and then it drops, right?
Mm.
So you
Yeah.
have a sudden spike for a day and then it drops. So that's again, so that's performance testing. Security. So yes, we need to cover a different maybe for all these things, but in security you have to understand what security are we talking about. Are we talking about network security? Is a person able to get inside a network? So we are all connected by the internet, and everyone is basically it's network of machines connected together, but with
Yeah.
certain restrictions or firewalls in place. So can I actually, as a novice user, can I bypass the firewall and get access to a database? Say a film database or a database which is selling products, and I can maybe tamper with the database, make the price zero of a product, and then try to buy that product. Things like that, right? So,
Right. Yeah.
so there is an aspect of network security. Then there is an aspect of application security. Can I actually cheat the software to think I am a admin person and grant
Mm.
me all the privileges so I can do anything with the software? So you have application security, you have network security. Can I penetrate the network? Can I hack the application? And then in the application itself, you have desktop, mobile, web applications, so different types of application security. So, and now we have device security, IoT. So you have mobile phones, you have smart speakers, you have smart tablets, smart cameras. Can you hack those cameras? So that's another type of security that needs testing. So a lot of testing that I've done recently are actually on devices. They're not even, they're software on devices which are not your regular laptops or computers. They're like a Chromecast device, like a smart light, like a smart cycle, a gym cycle, a gym bike. So things like that.
Right.
So that's aspect of security. Then you have cross browser testing. So you test it across different browsers. Accessibility. How does a blind person, a deaf person, a mute person, or a person who has limited visibility use a system? So focusing on that aspect. So that's accessibility testing. And there is something called as A/B version, A/B testing, which you might have noticed in some job applications. So what happens is that you give two versions of the same page, and you
Right.
see which page sells more products. So version A is shown to say 50% of the users, and version B is shown to 50% of the rest of the 50%. And in those two versions, you will see which version of the page generates more sales. So that's AB version, and that also
Right.
is has to be tested. So normally you talk about personalization and etc etc, but there is this aspect of testing as well where you have AB versions. And yeah, so yeah, these are the total aspects of testing, the different types which we need to be aware of and which can be covered in a different session.
Yes, absolutely. I mean, yeah, it's such a big insight to know like the big arena of testing, and yeah, definitely we need more session to cover each of these things. Security testing, and then now we've mentioned all the other different kind of testing. Yeah, we
Yes.
we should definitely have a few more episodes covering all of this. But yeah, for today, I already have a really good understanding. But is there anything else you'd like to add?
I think yes. Yes, as in not anything else, because I think we have covered a whole overview of testing and what it encompasses. So yes, people who are naturally curious, I think it's a good thing. But just because you are curious doesn't mean you can be a good tester. You need to have certain other skills as well. You need to be able to find information, uncover information, present that information effectively, and contribute to the overall quality of a system, a product, a software. So, yes,
Yes.
thank you so much again, Rinat, for all the questions.
Absolutely. No, thank you very much for all the knowledge and insights. I mean, that would definitely change the way I work or how I interact with rest of everyone else in whenever I'm working. So yeah, no, it's been really insightful, really knowledgeable. Thank you very much, Amit. That was all for in today's talk. Hope you guys all enjoyed. Definitely do check out our other talks. They all have different talk. We have covered a number of topics. We did go into various, in depth in various topics, and I strongly believe that would, each of these talk will give you insights on those topics quite. In a really good way. So yeah, definitely check them out. Feel free to subscribe, and yeah, hope to see you guys again next week.
Thank you so much. Bye.
Bye.